Okay. Well, this is Buzz Powell, as I mentioned earlier. It looks like we've got 15 people online right now for this planning meeting for the PG study as part of the 2012 track. And going down the list here, I know we've got a few people from Alabama, but can someone from Alabama just say here that you're online and participating?
Christy's here.
How about Alabama DOT? Randy Mountcastle, are you there? I know you popped up in the questions area. Randy is here. Okay, I'm gonna go with that, Randy. Mississippi.
We're here, Buzz. It's just me though, James Williams.
I appreciate that, James. Dennis, how about you? You still there from Missouri?
Yeah, I'm here with Joe Schreier and Jason Blomberg.
Howdy, guys. Appreciate y'all being on the line. Oklahoma. Do we have someone from Oklahoma online? Anyone from Oklahoma? All right, we'll come back to Oklahoma. How about South Carolina? South Carolina? I think we have someone here from South Carolina. All right, we'll move on. So we got South Carolina and Oklahoma that needs to check in. I know we had Clay Colwell on the line previously, but he seems to have dropped off from Tennessee. And then FP2.
I'm on here, Buzz.
Okay, that's Jim, sounds like.
Right, correct.
All right, I appreciate that. So we got Oklahoma, South Carolina, and Tennessee. Need to hear from. Well, we'll keep watching the attendee list and try to pick up when we get participation from those three states. But in the meantime, the clock's ticking, and I know everybody's busy, so I'm going to jump in here into the presentation, and I'll go back to the panel here in just a minute and make sure we have everyone online that we need to have online. Did the slide just change for everybody?
Yes.
Yes.
Okay, well, I wanted to start out by giving you an update on the sponsorship for the 2012 track. This is the list of the state DOTs and, of course, Federal Highway Administration and the private sector sponsors that are involved in this research cycle that we're calling the 2012 track. It's research cycle number 5, depending on which way you want to look at it. And, of course, the focus of this meeting is the preservation group. We want to try to begin the process of developing a consensus on what the PG study is going to look like for this research cycle. And in addition to the 7 state DOTs there, you'll notice that FP2 is in green, shown as a PG study sponsor on the private sector side. And we're very pleased to have FP2 on board with this experiment. When we started making the rounds at the Pavement Preservation Partnerships last year, last fall, and began to get feedback on our original kind of conception of what this experiment was going to look like, we became convinced that we really needed to have FP2 involved to help us to plan the experiment, and then to help us to execute the experiment. And then so we've been working with this group pretty significantly, I guess, throughout 2012, going back to the beginning of the year. And the experiment that we're proposing in this meeting, that is the NCAT recommendation to the PG study group sponsors in this meeting, is really the result of all the time that we've spent with FP2 to try to come up with a recommendation that we could make to you, to the sponsors of this experiment, that would be technically sound. So, the reason why we began that dialogue was so that we could really design and execute a sound experiment, and then FP2, I guess you would say, as a result of that, FP2 said, well, hey, we want to do more than just help you to design it and execute it. We want to be a funding partner with all the state DOTs. So they are an equal funding partner with the states, and we appreciate them being on board with that. And Jim Moulthrop will participate in this meeting as a representative of FP2. We appreciate you being here, Jim, and we appreciate all of the technical support that you and your associates have provided to us in 2012 building up to this experiment, and we look forward to working with you in this research cycle.
Great.
So the primary objectives of the PG study, as we currently perceive it to be, quantify the life cycle benefit of treatments that are included in the study. Of course, that means generally two things. We want to determine the time and or traffic that it takes to return to pretreatment conditions after they're applied. And in doing that, we want to really quantify the life-extending benefit of treatment applications on the underlying pavement. Now, in preparing for this meeting today, I actually had a couple of preview meetings with a state or two that was not going to be able to participate in the meeting this afternoon. So I've incorporated some of their feedback into the presentation that we're making to the larger group today. And one of the significant pieces of feedback was in our discussion about the type of testing we're going to do, the sampling and testing we're going to do when the treatments are placed, in order to really have an assurance that our construction quality is exactly what it needs to be to get for the experiment to be as effective as we require, and to learn the things that we want to learn from it. The mandate that we were asked to include by one of those states was, well, whatever we set up as our sampling and testing protocol for this experiment, it would be great then if that could be one of the products that would come out of this, would be what can state DOTs do as their work in pavement preservation potentially expands in coming seasons. What do they need to test for? How do they need to sample? How do they need to test? What types of laboratory procedures can we subject samples to in order to give us some predictive capability? So we added that as a third item here on our implementable findings that will result from the study. We can pause just a minute. I'm going to go back and check my attendee list. So I can make sure we've got everybody online and live. Okay, Mark Woods, I see where you're shown as being online, and I just sent you a pin so that you can speak, and as soon as you punch that in, then I'll take the mute off and you'll be ready to go, I hope. Otherwise, I think everybody is live. Well, the execution of this study kind of breaks down as you see in this slide. The first step for the PG study on the 2012 track is traffic continuation on select group experiment sections from 2009. That's going to be an important feature of the study because it provides us with a starting point for treatments that are applied on the track, but also because it's going to allow us to fulfill our fatigue life expectations that we have on those test sections. So where you've seen the bar graphs that we presented in the past that relate our multi-strain laboratory test results to measure strains on the track, and then we're going to continue traffic on those sections in order to see what kind of fatigue life we actually get so we can hopefully validate those expectations. The plan is to stop traffic on these sections when we hit trigger levels of distresses. And I'll talk more about trigger levels of distresses here a little bit later in the meeting because trigger can be either cracking or roughness increases. And I've got feedback from a couple of the states already about what they want to see as the actual trigger mechanism. But when we get to that point, we will apply consensus treatments to those test sections on the track. Of course, the state DOTs and that are paying for the experiment will make the final decision about what treatments we'll apply on the track and what the trigger mechanisms will be before we apply them. But a very important part of this experiment is the duplication and expansion of this study in off-track test sections. So for the first time, we're going to have test sections that we'll place on a county road, a local county road, where we'll pretty precisely monitor the accumulation of traffic and monitor performance so that we can complement in a really positive way that what we'll learn on the track. I'm going to check my control board again here. Okay, Mark, you should be live where I have you entered your PIN and I've freed you up there. Online, Mark Woods?
I am. We were getting set up. I think you might have mentioned something before. We chimed in on this slide actually.
Good deal. Good deal. We appreciate you being here, and you hadn't missed anything just yet, Mark. So we're doing this as a webinar because for the benefit of those of y'all who kind of came on late, because we got concerned with a high level of participation. We didn't want to blow a gasket on the web meeting and have people that couldn't log on when they tried to, just because we were overloading the account. So I appreciate y'all's patience. It's the first time I've done a webinar, and it's kind of challenging. I should have set the thing up so that we could manage it from another panel, because I'm managing it from the same computer that I'm doing the slides on. So y'all please just bear with me. So this is the layout for the 2012 track. And of course, we've got 46 test sections on the track, and I wanted to start out by providing you with kind of an update on what this research cycle is going to look like. You know, what you see shaded in color here on this slide, the red sections are structural test sections, new structural test sections. Those will be instrumented for high-speed response. Then we've got the green sections that are mill and inlay test sections. And then finally, the yellow test sections represent potential sections that can be involved in this preservation group experiment. So I'm going to focus on the yellow sections here for just a little bit. And then I've recolored them on this slide because in my mind, I kind of grouped these into three classes. And what you see highlighted in yellow on this slide is an OGFC section. What you see in red, those are dense graded mixes with virgin materials. And what you see in green, those are dense graded mixes with high wrap content design and construction. The thickness on all of these test sections is 7 inches thick. So, kind of in those 3 different classes, the recommendation for what we put in the treatments that we put in those sections is kind of in consideration of what we've used to build them. And all these sections were built as part of the 2009 research cycle. So we've got proactive and reactive treatments to apply on the track. And in terms of proactive treatments, this summer during track reconstruction, we would recommend that we apply a rejuvenating fog seal on that yellow OGSC section. And when we do that, we would probably apply the treatment to half of the section and leave the other half of the section untreated just to see what effect it has on performance. We've got two different sets of reactive countermeasures, and the first reactive countermeasure is as soon as we get to the trigger mechanism, and I've got cracking with a question mark by it because I've got feedback from 2 of the state DOTs that have said that they want cracking to be the trigger mechanism as opposed to increases in roughness that might precede cracking or increases in variability in strain measurements that might precede cracking, because the feedback I got from them was, well, on our networks, we only respond when we see distresses, so we want to see distresses on the track. So that's why I put that in there with a question mark by it, just so that we can talk about it here in this meeting to get feedback from all of you guys. But with each of those first reaction countermeasures, the idea is to maintain some length of untreated control. I'm trying to read questions here. The question is, what about friction numbers? Are we going to be able to get friction numbers on half sections, for example, with the fog seal? And the answer to the question is yes. We wouldn't subdivide these sections on the track in lengths that are shorter than 100 feet, because we know that in 100-foot sections we can do friction testing, and that would be part of the important data that we want to collect on all these treatments. Okay, so then on those kind of working our way around the list, the red virgin sections that I had on that previous plot, the recommendation would be to put chip seal, fiber mat, scrub seal, microsurfacing, and a 475 overlay on those sections as a first countermeasure. So when we hit the trigger distresses, that would be what we would apply. And then on the high wrap content sections, just do overlays on the high wrap content sections. Go with a little bit more of a robust attack on the high wrap content sections, because our expectation is that they'll have a higher fatigue life. If we see cracking on these sections, because they're full depth high wrap, I don't know how rapidly the cracking will progress or what the severity levels will be. So the conservative approach was just to go with the overlays on the high wrap content sections, although that's open for debate. Then when we reach a second level of distress, a second level or a recurrence of the trigger mechanisms, I guess you'd say, then we would go in and do plant mix, mill, and inlays on all of the distressed dense graded sections, and do micromilling and inlaying on the OGFC section, just as an idea to put forth before the group. Does anyone want to provide any feedback on these suggestions for the treatments applied on the track?
Hey, Buzz, this is Mark.
Hey, Mark.
Just a question. I noticed the first one, the proactive rejuvenator on the OGFC. Any reason why we would do that on just OGFC and not one of the dense graded sections too?
Well, that's a good question, and we do have some other opportunities on the track outside of those basic sections that would be good candidates for rejuvenators of different types, and that certainly is an option that we could look at. And we do have fog seals with and without rejuvenators on Lee Road 159. But within this group of sections, I'm showing it just on the OGFC, but certainly it could be part of the study in other areas. That's a good question. And I've been asked another question on my list here where I say chip, fiber, scrub. That's just kind of my shorthand abbreviation for Pavement. Some of these treatments may or may not be things that are familiar to some of the state DOTs, and Pavement is a chip seal where instead of just a single layer of tack, there's a double shot of tack with a layer of fiber that's placed in between it, and that's done with a specialty piece of equipment for the tack application, and then with a conventional chip spreader for the placement of the chips afterwards. And yes, Pavement is a proprietary product, but it is a product that there's been a lot of interest expressed in amongst the states. But it's a proprietary product, so that may affect everyone's willingness to leave it in the study. And of course, this is just that bar graph that I mentioned that is our fatigue expectations for the group experiment test sections, and you can see some of the highest bars there are the two high recycle content test sections, and then you also see a longer life expectation for the warm mix test sections compared to the hot mix control. So continuation of traffic until we reach these trigger mechanisms is an important thing, because it's going to allow us to validate these expectations in fatigue life that we have. Now that brings us to Lee Road 159, and this is a very busy graphic here, but it contains a lot of information that we're going to try to be very careful and step through in as much detail as possible. This is a plan view of 2,500 feet on Lee Road 159. And for those of you who may not be familiar with it, this is a county road that runs out of, it's access to and from Mark Marietta's quarry that's located here in Lee County. It's actually it's right around the corner from NCAT as you look down on a satellite view of Lee County. And it's longer than I'm showing here, but what we focused on is actually the 2,500 and I think 18 feet of Lee Road 159 that's south enough of the quarry that the road cleans up pretty good when you get into this section, and there's not like an excessive amount of dust associated with the quarry activities back there. But this is a plan view showing the inbound lane on the top and the outbound lane on the bottom. So as you drive from left to right, you're actually driving from north to south on Lee Road 159. Individual cracks are shown as lines, and interconnected cracked areas are shown as polygons, as enclosed areas. This is the same type of distress mapping approach that we used with test sections on the track. This is the map that we're using for planning purposes, but we're going to go out and run another set of crack maps before we apply treatments to make sure that we've got the most current information as possible. Okay, I've got a question from someone on the dashboard here about hydraulic performance in the OGSC, and we will continue to monitor that to make sure that that the seal doesn't have a negative impact, or at least to quantify the impact on the drainability of that mix. I'm going to go back to the attendees list and make sure that I've got everybody open. That question came from David, and I've got you open. You're not muted, David, so I don't know what is going on there, but it's showing that you're connected through a phone line. So I'll try to keep watching for questions, but maybe we can try to get you hooked up if you through the telephone. I'm not sure. So we will watch for continue to monitor permeability in that section. We do permeability testing quarterly here at the track. So moving back over to Lee Road 159, you can see looking down onto that crack map that there's longitudinal cracking that's pretty consistent in both the inbound and the outbound lanes from the 5-foot to 6-foot mark that is very consistently contained within that band. And the way we're laying these the distress mapping out in these sections, of course, all the test cells are 100 feet long. That will allow us to do full-size friction trailer testing on these sections, so that's an important feature. But we're differentiating performance between the inside wheel pass and the outside wheel pass on both the inbound and the outbound lanes. So we've only got 100 feet of test section, but we've actually got 4 100-foot strips for the purpose of characterizing performance of these test sections. And that's a change from a previous incarnation of the study as we work through designing this experiment with FP2 involved and experts in the pavement preservation industry contributing to our effort to design the experiment. They felt very strongly that the diversity that we would get by adding the inside lane to the study and doing both applying treatments to both the inside and the outside lanes would be a good investment. So we did change the scope of the experiment in that manner. Now the shading that you see on this layout is intended to give us an idea of what types of treatments are applied. And I've got another question here, so hang on, let me check this question. The question is about section length, and if you hang on just a second, I'll answer that question. That question will be answered. The question was, why do some of the sections look 100 feet long, and why do some of them look 600 feet long? And the answer to the question is there are 25 test cells, and the colored crack map graphic is a plan view. If you look at the bottom of this slide, you'll see what is kind of a schematic profile view, and each individual cell is 100 feet long. The reason why some of the surfaces look longer is because they're combinations of different treatments, and you'll see where I'm going with that here in just a minute. Cells 5, 7, and 12 will be crack sealed before the treatment is placed. Cell 5 is actually a part of the control because cell 3, 4, and 5 are control sections that we want. The only treatment that will be done to that is crack sealing in number 5. Backing up to cells 1 and 2, those are fog seals with and without rejuvenators. Cells 6 through 9, actually 6 through 10, will be chip seals, where you've got a number 7 chip seal going from 6 to 10, a number 89 second layer going from 8 to 9, and then a third layer of W10s in cell number 8. So that's kind of a single chip, a double chip, and a triple chip approach. So even though we're showing 400 feet there in that area, it's really 4 distinct 100-foot test sections. I think that hopefully that answers the question about section length. Every cell is 100 feet long. And all 5 of these cells that have a number 7 chip seal as the first layer, the surface is kind of a different combination of treatments, where number 10 is a number 7 chip seal that has had a microsurfacing layer placed on top of it. So that would be a cape seal. Number 11 is just a conventional single layer microsurfacing treatment, and number 12 is microsurfacing that's been crack sealed first. Number 13 is a layer of micro over a first layer of microsurfacing. Number 14 is microsurfacing over fiber mat, and number 15 is microsurfacing over scrub seal. So we've laid this out kind of like we lay out test sections on the track that optimize for constructability. And again, we appreciate the input from FP2, and those guys actually let us go out on some preservation projects so we could see how the treatments were applied and then better visualize how all this stuff needed to fit together on the track to optimize construction quality. I'm not seeing any questions here or hearing any questions. I'm gonna keep going through this. 16 and 17. Number 16 is the scrub seal, and 17 is fiber mat. Now 18 has also got a layer of fiber mat, but then at number 18 through 25 are different variations of plant mix. And the proposal for these sections is that the plant mix there be variations of the W6 plant mix that was placed on the 03 track by Mississippi, that is a screenings mix that has performed so well. 18 through 25 would be variations of that, where the farther right you go or the farther south you go on 159, the closer you get to the stop sign. So we would ideally have some robust mix as we get close to the stop sign. So the far right in cell 25, that's actually high polymer mix. 24 is a shingle mix, and 23 is a higher wrap content mix. I've got cell number 22 is highlighted there because we're going to try to do some type of a recycle section there, and we're trying to lay out this work so that it coincides with work by Virginia, where we're going to have a recycle plant on site that we could also use down on 159 to do some version of that in that section. And I've been asked the question, what about the cell that has W10s as a surface layer? And that is Georgia's triple, what I call a triple chip, and it's attacked with 7s and attacked with 89s, and then a final layer of W10. So essentially, you're putting together kind of a dense mat with aggregate, where you're going with progressively smaller sizes of aggregates with the placement. Georgia is not part of this study, but there's a lot of interest in that treatment with the other states that are part of this study. And the reason for that is because Georgia has done, they started out just doing that on lower volume roads, but they've had a lot of success with it on some pretty significantly distressed roadways. So they're trying it on higher volume roads, and my understanding is they've had some amount of success with that. So we're including that in this experiment. Now some notes to make on this. I personally think that it would be ideal if we committed to one general type of aggregate to use for the different treatments, and two good choices for that would either be limestone or granite. I think probably if we had to look at the footprint of the sponsor states in the study, granite is probably the more commonly used material for surface treatments of different types. But there's a lot of microsurfacing that goes down successfully with limestone. Point being, if we start to mix the types of aggregates, and some stuff goes down as limestone and some stuff goes down as granite, then we may confound the outcome of the study just a little bit in terms of how the different sections compare to each other. So my recommendation to us would be to pick one or the other. And we need to move quickly on that and make a decision, so that we can begin the process of really pinning down the designs. Now the group through FP2 that worked with us to help to really come up with this recommendation to make to the states is Jim Moulthrop, who's on the line with FP2. And Jim, I'm gonna assume it's okay for me to name some names because you guys have invested a lot of time in trying to help us come up with a good, solid technical recommendation here. But Mike Buckingham with Colas and Tim Harwood with Vance Brothers and Mark Ishii with Ergon. We've got a list of the emulsions that we're proposing for use in this experiment, and for the conventional fog seal, the recommendation is a CSS 1H. For the rejuvenating fog seal, it's a CMS 1P. And then that same material would be used for the scrub seal. For conventional chip seal, it's CRS 2L. And for the microsurfacing, it's a CSS 1HP. I ran those grades past a couple of the states previous to this meeting, and they thought that was a really good idea to use for the different grades of emulsions. I'm reading some questions here, so you guys bear with me for just a minute. Okay, I got some feedback here from a state that says they use lightweight aggregates as their surface stone for chip seals, and of course our challenge here is we got to come up with a consensus material to use for all these that has as much relevance as possible to all the states that are in the study. And then there's a question about the 475 mix designs. What design criteria? My recommendation would be that they be designed in accordance with the most recent recommendations for 475 mixes. And the starting point for those designs would be the materials and the proportions that came from the track in W6, but they would need to be designed fully in accordance with the latest recommendation. I just got a question about, is there a particular reason for using a 2L as opposed to a 2P? And that point would be kind of up in the air. It kind of depends on the preference of the states. But one of the states that said they'd be good with an L is a P state, and they said that, yeah, we'd be good with that. I mean, I don't have a dog in that fight, other than, you know, we want this to be as buildable as possible. And we've got construction. You can imagine the logistics of this. We have relatively very small quantities of emulsions that are going to be used to build all these test sections. So the more we can kind of fine-tune this and get representative materials that are acceptable to everybody, that will limit the number of different products we have out there, the better off we'll be. I don't see any more questions at this time, so I'm going to keep moving forward then.
Hey, Buzz. Sorry, this is Mark.
Hey, Mark.
I don't know how to. I guess I was too late to type one in. I'll start trying to chime in time. Just a thought about the CRS2L. I think each state has a different spec for that material. Some of us will allow a 2L or a 2P so long as they meet a certain elastic recovery, ring and ball, and ductility stuff, which are all approximately the same. But just a thought, we might look into that, because the bottom line is that they have the penetration value and an elastic recovery value, a polymer or latex content. We might see what we can do to just make sure whatever we're getting has enough to meet the ring and ball and elastic recovery for most states, but not all of them.
Well, and Ergon, as I said, Mark Ishii being part of the group that's helped us with this, Ergon has offered to provide the emulsions that we would need for this, and the benefit of that is they're the biggest emulsion supplier in the country, and they have a good feel for the requirements in all the different states. So what I'm proposing right here is just kind of a starting point.
Okay, thank you.
Point well taken. I'm going to check the attendee list and make sure I don't have anybody who's unintentionally muted here. Regarding the installers, Vance Brothers and Colas, as I said, have been part of our working group, and the proposal has been made that Colas install the Pavement, and again, that is a proprietary technology, but they've offered to install the Pavement, and then all the other treatments could be applied by Vance Brothers, and I hate to speak for either Colas or Vance Brothers, but they both expressed an interest in helping us with the installations of these different treatments, and I just wanted to make everybody aware of that.
Hey, Buzz, this is Nelson Gibson. Am I coming in?
Hey, Nelson. Yeah, you are. I think I had you muted.
No worries.
Sorry about that.
I got a question. Did you try to get your arms around trying to normalize in the different cells here? How did you get your arms around trying to normalize the amount of cracking or balance the amount of cracking in the different cells?
Well, that's a good question, Nelson, and I guess before I address that, I got a note from a non-granite state that they voted for limestone. So we're going to have a bit of a time, I think, trying to come up with a consensus surface treatment aggregate. But that is noted. I appreciate your feedback on that. Now, if you look at the distribution of distresses in the inside and the outside lane, and the left and the right wheel paths going in both directions, we really did try to target cells that provided a good distribution of distresses. And Nelson, I don't think you and I have talked about how we're going to differentiate performance on this, but I think you'll see the logic behind doing it the way we're doing it in order to account for the fact that we've got different levels of distresses in all the various cells. But I will point out that if you look at cells 3 and 4 on this graphic, those are the control cell, or both of those are control cells, where in cell 5 we've got crack sealing, and that's kind of a treatment in itself. But look at cells 3 and 4. The reason why we set both of those up as controls is because there are pretty significant distresses in number 4 and not much of anything in number 3. And it didn't appear to be correct to pick one or the other, so we really wanted to have a reasonable spread there, and we tried to do that going left to right all the way through the length of the road out there on 159. Noting that as you get close to the stop sign to the right and the distresses get significant, we've got stiffer plant mixes out there as you go progressively to the right. So we worked with FP2 to try to figure out how to get things in the right place and ensure that we had a significant amount of spread in each. I got a question about crack sealing, and the proposal was made that we do route and seal versus hot lance sealing. We can, I think in the next slide you'll see how we might be able to compare the types of crack sealing and kind of split that out a little bit, but what we do is open for debate. That's what the group has to decide. I got another question. So yeah, all these treatments are going to be applied in both the inbound and the outbound lanes. We've assured the county that we'll keep this road open for commerce and for travel for residents that live on this road, and there are only a handful. But at this point, again, working with FP2 with traffic control provided through our paving contract with East Alabama Paving, we feel like we can do both the inbound and the outbound lanes and still maintain traffic on this road. So yes, that is the way it's going to be done. So what I wanted to do now, and I think this is going to kind of clear up some of your questions. By the way, I guess before I move on, you'll see some tick marks on the very top and the very bottom of this graphic, and you'll see orange and blue dashes kind of that follow along the edge of the pavement. That's our shorthand for noting that there are driveways and turnouts and gates that go into farmers' pastures, that type of thing. They're there are features on the side of the road that we had to respect as we laid these test sections out, and I left those in there just so you could see that we were trying to be as careful as possible in our planning process. So, as I said, what I want to do here is focus on one of these cells, and the one that I kind of randomly picked was from 1,000 to 1,100 feet. And I want to zoom in on this a little bit because looking at the map on this scale can be misleading. So when I zoom in on that cell from 1,000 to 1,100 feet and stretch the distresses out, it's a little more obvious to you that we have a lot of longitudinal cracking, as I said, from that 5 to 6 foot distance, but very consistently from 5 to 6 feet. So we're not going to map that. We're going to monitor it, but it will not be part of the distress record for the sections. But even though these cells are only 100 feet long, because we're doing inbound and outbound, and because we're separating between the inner wheel pass and the outer wheel pass, we actually have 40 5-foot wide by 10 feet long subcells that we will independently be monitoring the recurrence of distresses in. So keep in mind what we're doing with this is we want to determine with each of the treatments, with the distresses in place that vary by cell, we want to see how long it takes to return to pretreatment conditions. So we don't have any plans. We will not be comparing one cell to another cell. We're monitoring the independent condition as it changes in each cell, and in fact in each of the 40 subcells that make up each cell. So we're going to be collecting a lot of data with this effort and differentiating that data to monitor the reflection of all these distresses. So as you look at this particular cell, 100-foot cell, many of these subcells don't have any distresses in them at all. And in breaking the data down like this and in monitoring the condition of the cells in this manner, really what we have is a proactive versus a reactive type of an experiment where the condition of each of these cells is going to vary pretty significantly, and we'll be monitoring for the recurring distresses in each of those cells. Does anyone have any questions about that approach? Again, we've been working really diligently with FP2, and we appreciate their support and their feedback on this because and Nelson, a lot of this started with the interaction that we had with the preservation partnerships last fall and with FHWA last fall to try to land this experiment exactly where it needed to be to achieve the objectives that we have laid out. And we feel very good about this approach. So looking at kind of a theoretical pavement condition curve, recognizing that when a road's in pretty good shape, the things that you do to it really are preventive in nature, and then when it deteriorates, you get into more of a rehabilitation type of a function, and finally, if it deteriorates so far, you get down into a reconstruction type of an activity. We really feel like that in each of the cells, we have a good spread of data in the upper two parts of this curve. So we think we're going to get really good feedback in terms of performance from prevention and rehabilitation on this road, proaction versus reaction, which is providing the state DOTs with what they need to do network level type work when they might be behind the 8 ball and just trying to make the best of the resources that they have at hand, and also to provide data for agencies that are ahead of the curve and using these technologies really the way they were intended for asset preservation. So we got a good spread of data, and then on this kind of theoretical plot here, each of those data points would be a subcell in a cell. So this family of points are all picked from a single cell out on the track. So actually you'd have 40 little dots like that make up one of these test sections out on Lee Road 159. So in this case, if we apply treatment A, then and it comes off of that point and kind of resets it upward, and then we continue time and traffic, and we get a certain rate of decay as a result of the placement of that treatment, compared to treatment B in the case of this schematic, where we may spend more on treatment A, but we get twice the time for that pavement to drop back down to pre-treatment condition. Then treatment A, even though it costs more, may be a very good investment. And then beyond those points, the shapes of those curves may be completely different down below where I've defined them in terms of this plot here. So really the end game for all of this is we intend to develop a unique curve for each of the treatments that are included in the study, that the states choose to include in the study, where we relate the time or traffic to return to pre-treatment condition to pre-treatment condition. So when I say that, I mean that roads are in better condition. If you have a choice here between, say, a single chip and a triple chip, the triple chip is going to cost you more to apply, but you get a longer life at the same pre-treatment condition than you do on a lower cost alternative in terms of this sort of theoretical plot. So these curves that will result from this effort can then be dropped into the decision trees that state DOTs, many of you guys on the line, have developed, and then you can plug in your bid prices for the different treatments, and you can have your decision tree tell you based on your pavement distress data on the ground for specific projects what treatment is the best life cycle investment. So this will provide you with the starting point for really objective selection of preservation alternatives, with the idea being that over time, feedback from your pavement management system from selected alternatives will allow you to calibrate these curves derived from Lee Road 159 to your network, your materials, your contractors, and your climate. But they'll give you the objective starting point that you need to make the right economic decisions. So this is kind of the engine that is missing from many of the decision trees that have been developed recently by state DOTs. Now, I've been asked a question here: how confident are we that the conditions of the sections will change in 2 years? Well, we know the condition of the sections are going to change. The question really is, how significantly will they change? And for some of the treatments, some of the more robust treatments, I think that if I could answer this question, then maybe we wouldn't have such a great need for the experiment. But the reality is we don't know. We've got to wait and let the data speak to us. It may be desirable by the group at the end of the study, since on Lee Road 159, the damage that's being applied is not damage that we're funding with fleet operations on the track. It might be that we want to extend this experiment to extend the performance curves out and maybe even look at different treatments. And that would be a decision that the group would have to make. It depends on how pleased everyone is with the quality of the output. But really, that is, I guess, that's yet to be determined. So we don't really know what the answer to that question is. I will say that we have a non-disclosure agreement. We have a data sharing agreement with Mark Marietta, and they're going to provide us with all their load records going in the inbound lane, running in empty, and the outbound lane loaded out for customers. They're going to provide us with those records, so we'll have a date stamp, a time stamp, and a load. And some loads from Mark Marietta actually go over to East Alabama, and East Alabama hauls in material that does not come from Mark Marietta to supplement their mix production. So East Alabama Paving has also committed to sharing data with us. So we'll have a complete record of all of the truck traffic on that road going in and coming out that'll provide us with the kind of the foundation upon which these curves will be built. The idea with it is that on Mondays we do all of our performance monitoring on the pavement test track on Monday because the fleet is idle, and then we would have Tuesday through Friday to go out and do performance studies on Lee Road 159. Now, you're probably not going to see any pictures of us crawling around on mechanics creepers on Lee Road 159. We'll be doing our distress surveys in more conventional network level ways, but it'll still be pretty high resolution because we're going to be doing regular data collection as opposed to annual or biannual types of data collection in a network application. So we'll be using video cameras and an inertial profiler to collect rolling data out there that we will occasionally supplement with visual inspections. But again, the idea is that these curves that we'll provide to you guys as a product of this effort are going to be calibrated with your network level pavement management data. So we feel like we really need to use network level methods on 159, or you'll have you'll have a calibration effort that won't be as solid as it needs to be. You should require less calibration if we use methods that are similar to what you'll be using on your open infrastructure. So that was the last slide that I had in terms of guiding the talking points that we would have in this meeting, and we need feedback from everybody on several very important issues. Let's see, I got another question. We do have IRI data before treatments that we've used for planning purposes. We'll have more IRI data. We'll do a set of crack maps, full set of distress characterization right before the treatments are applied, and we're gonna try to do weekly performance data collection out on 159. That's going to be our plan going into it, and because we're using mobile methods, network level methods, we think we'll be able to stick to that plan. But we do weekly data collection on the track, and we hope to do weekly collection out on 159 to get the highest resolution view possible of the data. Well, we need feedback from everybody by my notes on the following issues. We need feedback on the trigger mechanisms, feedback on the aggregate sources, feedback on the emulsion grades, and feedback on the installers that we would use. And all of this kind of is underneath the bigger feedback we need on the concept of the experiment. If you feel like there's something else that needs to be included, or if you feel like we've gotten off on a tangent with this and we need to kind of pull it back around, again, we need that feedback from you on that because this is your experiment. Now, I got another question. The question is about NovaChip. We have not talked about putting NovaChip on 159. We have used NovaChip on the track in the past. Now, it might be easier to try NovaChip on the track than it is on 159. Reason being, it's really hard to do a good NovaChip application in a very short distance because it's just set up to go down for different reasons, to pave long stretches very, very quickly. And on the track, the two times we've done it on 200-foot test sections, we've had a very difficult time getting a good smooth application. We always have kind of a rough time of it because you just get started up good with NovaChip and you're done. But it certainly is an option that could be considered in both places, but it'd probably be better suited for the track. Does anyone want to comment on the besides the NovaChip question on the scope of the experiment that we've defined in the recommendation for 159? And I just got a comment that the concern that I expressed about NovaChip in a short run. Yeah, I mean that one of our biggest challenges on 159, which we spent a lot of time discussing with the FP2 working group, is how do we get really good quality in these short test sections. And kind of along those lines, Lee County has indicated that they're going to help us to identify some pavement surfaces that are as close as possible to where we're working on 159, like possibly on the other side of County Road of Lee Road 10, where we can do practice shots with these treatments. So we're going to do setup and staging in East Alabama Paving's wrap yard, which is up at the north end, or thinking about that crack map, the leftmost part of that crack map out on the far left. So we'll be setting up and troubleshooting up there, and then doing practice shots probably on the south side of County of Lee Road 10, and then backing up and doing the real deal up on 159. And we're going to have to do put down a lot of paper. We're going to be doing we'll have a lot of startup and shutdown waste associated with this, because it's going to be tough to get the quality that we really want, that we have to get. Just like on the track, on track test sections, unless we're studying construction quality, our job is to get test sections as perfect as possible, and that's going to be our same philosophy over on 159.
Hey, Buzz, this is Nelson.
Hey, Nelson.
I'm not a smoothness person, and I'm honestly still cutting my teeth when it comes to preservation. But on the county road, it seems like the trigger it seems like the trigger is only going to be cracking, given that, and I don't think that's a bad thing. I'm a little more biased to cracking myself, but given, I think, because they're 100-foot sections, it seems as if, and I say this because recently I learned with smoothness, I think you need a minimum of 200 foot. I'm not sure about that, but it's not a question. It's more of a comment that it seems like on the county road that the trigger, the best trigger you can study would be cracking.
Well, on the county road, there really is no trigger that we can pick, because the county road has existing distresses, and we're going to apply these treatments all at one time on the county road. Now on the track, we won't do that. On the track, we'll mobilize and apply treatments as we encounter distresses. But on Lee Road 159, it's more a function of characterizing what we have and applying all the treatments, and then monitoring the treatments so that we can determine how they perform and how their condition relates to pretreatment condition.
Okay, correct. I follow you. You straightened me out a little bit there. But I think what I was just trying to say is the pretreatment condition, that value is cracking. I think my question is the pretreatment condition in what you showed in the conceptual schematic, that is cracking, or did you have something else in mind?
Well, we've done a lot of characterization that's not in that graphic. That graphic is kind of the simplest thing to visualize, but we've done coring, and we've done FWD testing, and we've done extensive roughness testing on 159, looking at the roughness numbers in a bunch of different ways, and we feel really good about the layout of these sections, and where we've put everything from a suitability and a constructability point of view. Roughness will be part of the assessment process, but one of the challenges that we're going to have here is that those performance curves that I showed you, that will be the product for each of the state DOTs, we've got to collect the data in generic enough format so that we can calculate condition in any number of ways. So, you know, the two simple terms to visualize, of course, are cracking and roughness. But you've also got texture changes that are going to occur, raveling that's going to occur, friction changes that'll be part of it. There's a lot to consider, and our objective will be to collect the data in a generic format so that we can output performance data any number of ways. Question has been asked, how do we decide which treatments to put on the track and where to put them on the track? That needs to be decided. You know, I have proposed different types of chip seals and microsurfacing and asphalt overlays, but we've got to figure out where we want to put it. We've got to figure out if that's what we want to do on the track. I mean, it's up in the air. The group has to make that decision. I mean, I've got a recommendation that I have developed that that uses test sections S9 through S12 and N5 to look at fiber mat and scrub seal, chip seal, microsurfacing, and overlays. But the actual selection of the location is, we've got to work that out. I mean, the group needs to decide if it approves of that recommendation, and if it does, should we use random numbers, you know, for example, to pick what goes where.
Hey, Buzz, it's Mark.
Hey, Mark.
Can you go back to the slide where it started with, it had the 3 categories of treatments we were going to do following these triggers? Started with the proactive rejuvenating seal and then the 2 reactive measures.
Yeah, let me get back to that. Is that what you're looking for?
Perfect. What I was thinking of is for these, this is my opinion, just for the 3 categories, we would have 3 different levels of triggers. And, you know, that would define, obviously, the proactive rejuvenating, no cracking at all, would be the lowest distressed, and then increasingly distressed with the second and the third. Do you guys at NCAT, do you have kind of a seed value of what you think would be a good trigger, you know, as far as the amount or level of cracking or texture or any of those things?
Well, when we typically on the track, Mark, when we start to see cracking, at least in the past, it has developed pretty quickly. So when we maybe see more than a certain, you know, cracking, so many feet of cracking within a test section, or some crack density within a test section, we're gonna, once we hit triggers, kind of the magnitude of cracking is not so consequential, you know, because when it starts, it typically progresses pretty quickly. So we're going to need to mobilize and apply the treatments within a very short period of time, and that's been something that we've been concerned about trying to cost out and plan for the logistics that would be required to support it. Now, as far as this slide is concerned and this plan is concerned, the fog seal would be applied on the OGFC and potentially on other test sections on the track. That would be done in this summer when we're rebuilding, before we start our fleet operations. What I'm showing is the first countermeasures. When we see cracking in the group experiment, the treatments that we would apply in response to the cracking with this recommendation would be chip seal, fiber mat, scrub seal, microsurfacing, and 475 overlays on the virgin sections, and then possibly overlays only on the higher wrap content sections. Now, when we get the stresses again show up in these sections and they begin to deteriorate, presumably some of them could deteriorate rapidly, then we would go in as a second measure and do milling and inlaying, or micro milling and inlaying. So that's kind of the way the logic works out on the track.
Okay, I can just to speak for Clay and I, or to speak for Tennessee, what we'll probably do is look at this slide and a couple of things you were just saying and get with our resurfacing committees and ask them their opinion of what they would consider a trigger, try to find some objective, because we make decisions based on our own personally calculated pavement quality index, which is a combination of mostly IRI and a couple other things. So we may share that with you in an email. This is the number that our regional resurfacing people are looking for before they put these couple of things on here. So we'll send you that in an email here in a day or so. That's all.
We need that really from everybody, not just for the decision-making process right now to develop consensus, but for reporting data throughout the experiment. Then we'll want to report data to Tennessee in the format that means something to Tennessee. So what you just explained, most states kind of have their own version of that, and we will seek to report the data in a format that has the most meaning for each one of you. So it'd be very helpful if everybody can send us that type of information. And I've got some graphics that I've worked up that kind of go behind this slide, and I'll be happy to share that with everybody. Any other questions or comments? Does anyone see a big red flag in what we've proposed that would that they feel like some major course correction needs to be taken to correct? And we can do emails later if you're not comfortable discussing it in front of the group. I'm getting some positive feedback here in the questions. I appreciate that. Again, we appreciate FP2 working with us on this, because all we want to do is meet the needs of the state DOTs, and their support in trying to develop a technically sound recommendation was really, really important, and I can't really thank them enough for that. It's been a good learning experience for all of us. Well, what we'll do, as I said, I recorded this presentation, and it'll be posted and available online, and you can go back and review it if you'd like to review it, and then we'll send a copy of the slides out, and I'll add a graphic mark that provides some explanation to this slide on what we're doing, what we're recommending on the track, and then we'll vote by email, I guess, to try to figure out which way to go with the aggregates, because we want to get the experiment to be as suitable as possible for all the states that are providing funding to make it possible. Okay, I got some good feedback from several states about no red flags and need to move forward, ready to move forward with more specific planning. Well, I appreciate everybody's time, and if there are any other questions and you'd like to send it to me, please do it now, and if you want to put something in front of everyone just by voicing your view, then we'd appreciate you doing that also. Getting more good feedback here. All right, well, we appreciate everybody's time, and I'm personally very excited about how all this has evolved, and the whole 2012 research cycle on the track and on Lee Road 159 is just it's going to be great. It's going to be a tremendous effort. It's going to produce a lot of value for state DOTs, and I don't know if Randy's still on the line or not my director, Dr. West, but I got to give him credit again for Lee Road 159, because I actually argued against including that in the experiment, and he felt like it was the right thing to do. And as this thing has evolved and moved forward, I have to say I agree now that it was essential that we get this included. One last thing to mention about 159 is, and this has been an important part of the discussions with FP2, is the protection that some of these treatments provide against moisture intrusion is a big component, a big thing that we want to study on 159, and we do have a plan to do subsurface moisture content testing, probably quarterly, possibly more frequently, and we're working on some methods to make it easier for us to make those types of measurements on a regular basis, and moisture, subsurface moisture is going to be an important part of the study, so we do intend to document that. Well, all right. Well, I'm going to shut her down if there aren't any other questions, and at this time I'm going to stop recording. And we appreciate everybody's time, and we look forward to working with you to pin down the details of this study.